Okay, in this video we want to talk about how we can add forces to our actors. Okay, to start off with, we need to make sure that we have simple collision set up on our static meshes. So the meshes that we want to use for our objects. Under starter content, I'll go to props and we have this sm_chair. Now you can use what you want, but I'm going to use this chair as an example. Okay, so here it is, and we can visualize the collision. So you can see the simple collision as it is applied here. You can also generate collision. So you can go to collision and then you can add simplified collision. You have a few algorithms that will create a collision for you. You can remove collision, so you can also left click on it and move it around and such if you want to do that. And you can delete that selected collision and duplicate it and so forth. Now in this case, the collision is set up pretty well for us. So I'm not going to make any modifications to this, but I wanted to show you like where you can do that just as a recap. I'll probably cover collision in more detail in the Unreal Engine Foundations module. For this, again, we want to try and stick for the most part to the C++ stuff, but basically as a recap, the collisions are in here if you want to add or remove them, and you can view them clicking this button. So we need simple collision applied to our static mesh object, because that is what the Unreal Engine physics system is going to use when we simulate physics interactions on these objects. So it's not actually going to use the complex collision or the object itself. That would be very expensive to simulate unless you have a very simple object like a cube or something like that, right? So instead we want really simplified collision, and we'll use that with our physics simulations. So we already have that set up. We don't have to do any manual setup ourselves. I'll just close out of this, and I'm actually going to create a new level. I'll select this default one. That minimal default one is not that great for me. It's kind of awkward to start off with. Press and hold Alt, I'll left click and drag that chunk out. Rotate that around. Something like this. I just want to create a section where we can spawn the actor so it flies off kind of into this wall. So nothing special, nothing in particular that I want to do here. You can rebuild the lighting if you want to do that. And so again, I'll drag out my chair. You can press escape if you want to get rid of the handles. Okay, I'll create a new folder. Call that maps, and I'll save this map. I'll just call it forces or something like that. Under edit, project settings, maps and modes, I'll just go and set that to forces. So I'll actually create a new C++ class and I'll call that chair. So new C++ class. It's going to be an actor again. Now I would like to note that if you click on show all classes and you search for static mesh actor, for example, you have static mesh actor. You can see that inherits from actor, and it already has a uStatic mesh in that. So you can already add a static mesh. So you don't have to set that up yourself and attach it to the root component and so forth. The problem with that is if you want to create an actor that derives from static mesh actor in this case, that can give you problems. So it does not have all of the functions kind of laid out for you. So tick and begin play and all of that. You have to set that up yourself. And also that uStatic mesh is private, that variable. So if you want to use it in your class that you derive from that, you can have problems. So I went ahead and I created this class. Just as a quick demo, you don't have to do this. You can see I called it demo static mesh actor, and that derives from static mesh actor. You can see the class is very clean. if I right click on this and go to the definition, actually I'll just pick definition. You can also just pick definition. You can see we have the static mesh actor that derives from actor, okay, as we did previously. And as you can see, it already declares and initializes this use static mesh component for us. But the problem is it's private. So for this to be really useful here, it should probably have been protected. You'll also notice that if I go to the .cpp file, you can see it's very clean, okay? The tick function is not written out for us. Same with begin play and all of that stuff. So we can go and write begin play and the tick function and all of that stuff out. But as you can see, this will not really save us time. So it might feel like this will save you time, but you'll actually waste a lot of time if you start off with a static mesh actor. You have to type out a lot of stuff that is simply provided to you in the actor class itself already. But the static mesh actor one is useful if you want to create a blueprint from that. So if you just need a quick actor that already has everything set up so you can add a mesh to it, then this one is fine. But for this here, I'll click on actor and I'll click next. I'll call it chair and I'll create that class. So we want the root component to be a static mesh. I'll call that something like chair component. Go over to the CPP file and make sure to type this out properly. You don't want a U here, you just want static mesh component .h, so you have the include, and then here we create the sub object. So once that is created, we want to set the root component to that chair component. And I'll build that and we'll see what we get. In the output we don't have any problems or errors. So I'll right click on my chair and I'll create a blueprint. Select the folder, call it chair_blueprint, and I'll create that. Okay, so now we want to set up the class defaults. You can see the static mesh component shows up, but you can see we don't get anything in the details. So what I need to do is back in Visual Studio, if you remember from the previous videos, is we need to specify this as a U property. So I specify that as a U property. So this is now again available to the reflection system, and I say visible anywhere. Control B to compile that again. And now if we select this, then this details panel should populate. We can click on this drop down, look for chair, I'll select that. And that should populate both the mesh and that element 0 for the material, so the material for the chair. I'll compile and save that. Now we can drag one of these out. I'll just delete this other chair that I added previously. We'll add a few more things in here to bump this into a bit later on. But for right now, I just want to focus on this single chair. I'll move that around a bit, rotate it around a bit. Now if we click play, we expect this to fall down or something, right? But it won't by default. And again, I'm setting this to simulate. And that's because we have to enable physics on this. So I'll go back, select that chair component. And with it selected, in the details panel, you scroll down, you'll see under physics, you can simulate physics. This is currently set to false. If you hover over this, it will give you the tooltip. So if this is false, this will be fixed or kinematic, and then it will only move where it is told. Just cancel that. Now for static mesh component, simulating requires simple collision to be set up on the static mesh asset. So I talked about that earlier in the video. Okay, that is step 1. You need to have simple collision to be set up on that static mesh that you want to use in the slot. Okay, so I'll just enable simulate physics. You have various options, so enable gravity. I want to enable that, make sure that's enabled, because we want this thing to fall down, and the rest we'll just leave as is for now. Compile and save, and if I go and play this now, you can see this will fall around and we'll get some physics simulation. Now I would like to note that you can turn on the collision. So click this checkbox here. The shortcut is Alt-C. Okay, now you can see the collision box. So I'll just stop here for a second. You can see that outline, that wireframe. So that again is in the show menu, and that is collision. So at this point, I'll just save all. Okay, so how can we add a force to this? And we'll start in the blueprint section. So I have the blueprint open. We can drag off a reference to this component. So if you're familiar with C# and again C++ as well, we have the dot operator. So depending on if it's a pointer, then use that strange arrow operator, the accessor operator, and that is how you access the members of that object. And again, this is an object now. This is a sub-object or an object that is part of this actor. So if you have an instance of this in the world, as we do here, that is an instance or an object, but attached to that you also have objects, in this case this chair component. And how do we access the members of that? Well, instead of doing a dot or the arrow operator, you drag off from this output. Okay, now we can do add force, for example. We want to use force. You can see this is like a thruster, good for adding a burst over time. So instead what we are going to do is we're going to use add impulse. Under physics we have add impulse, because we want to add an impulse to a single rigid body for a one-time instant burst. So we don't want a continuous force applied, we just want a single burst, a single force applied when the game begins. So we'll use add impulse, and in X, since you can see X, if I select this arrow here will point in the positive direction, and I want that to kind of fly into that wall, right? I'll set this to something like, maybe something like 100,000, and I'll have to hook these two up. Compile, and as soon as I compile, you can see that we get an error. And this has to do with, you can see in the compiler results, it actually shows us chair component is not blueprint visible. It's not blueprint read only or blueprint read write. And that again is on the C++ side in the U property. Before we move on, we'll have to go and fix that. So I'm doing blueprint read only. I'll only do blueprint read write when I know that that is specifically what I want to do. But in this case, we only want a reference to this uStatic mesh component. So I'll have to build this again. Just do Control B. Okay, this is finished compiling. So I'll go back to the editor and I'll compile this blueprint again, and you'll see that warning goes away. I'll go and play this or simulate this, and you can see that will apply as soon as we click play to start the game. That will apply an impulse or a force to that object in the direction. So if I left click on that, you can see more or less where that vector points to. Okay, in the X direction, it's going to apply an impulse in that direction, and that will send my actor flying off into the world. Again, we have some nice physics simulation going on. Alright, another thing is how can we be sure like what we can plug in into this target. You can see it says primitive component and it's an object reference. But if you remember in C++, this is set up as a uStatic mesh component. I'll just Control C to copy that, and I'll open up Unreal Engine again. I'll actually just delete the stuff. We won't be using it. In the next section, we'll refactor that add impulse back into C++. But for right now, I just want to show you, you can go here to actually go back to the level editor, go to help, and then API reference or documentation. I'll right click and I'll click paste. So I'll just go and search for use static mesh component. And then we can see the inheritance hierarchy. You can see use static mesh component again is a U mesh component, and that is a U primitive component, which again is also a U scene component. So you remember that took in a primitive component, and again because use static mesh component is a primitive component, that is why that add impulse accepts that as a target. So just a quick note on that. So if you want to take a breath here, I'll just save everything. If I click play, we should not get an impulse. It still simulates physics though. Alright, so in the next section, we'll take a look at how we can do that in C++. So moving on, in the public section, I'll create a variable. And I'll call that impulse velocity, and this will be a float. U property and make this edit anywhere so that we can edit it. If we want to change the velocity, then we can do that in the editor, in the details panel. Okay, I'll set the impulse velocity in the constructor. And what we can do with the chair component, I'll just demonstrate in the constructor. You can see that we have access to set simulate physics. You can set this to true by default. Okay, so I have access to those options that we've seen in the details panel, previously in the blueprints. You can set them in here as well. But in this case, I'll just set those in the blueprint, so on the class blueprint, instead of doing it here. But if you know that that's what you want by default for your class, you want to simulate physics by default, then you can set that up in this way. Now, similarly, in the begin play, I want to add impulse, and you can see this takes in an F vector. Okay, so on begin play, event begin play, as we've had it before in the blueprints, we have now refactored that, and we now have that in C++. So all of the classes that derive from this, all of our blueprint classes and their instances will have this applied. So we add impulse, it takes in an F vector, and I'll just do Control-Shift spacebar. You can see these other parameters have default parameters set, so we don't have to worry about those in this instance. So add impulse, I pass it that F vector. In this case, I just create an F vector right in here, and then I pass it the impulse velocity. So x, y, z, we know from testing previously in blueprints that we want to set that to x, and we want to leave y and z to 0. So I'll build this again. Okay, the compilation is complete. So what I'll do is I'll go back to the editor, and if I play this now, you should get that impulse applied to this actor. You can select it. I did not give that a category, so it'll be under chair. So you can give it a custom category, otherwise it's going to default to this chair name now. So you can increase it or decrease it depending on what you want to do. Something like 1,000 is just not going to do much. Even 10,000 doesn't do much. You can play around with the values that you like, and because this is set up to 100,000, I believe, in C++, you can see we get this revert, and so that is set up in the constructor. So that is why this is the default. And now we can throw chairs around in our game. So that was a quick look at impulse. I would like to note that you can also, if I go back, you can add force. You can also add torque. So add force, add torque, and you have many other options. So that is going to wrap up this section.